This lesson will review some concepts on area from your middle school years. Recall that we find the perimeter of any polygon simply by taking the lengths of its sides and adding them all together. So in this table for perimeter, I'm going to say to find the perimeter of any polygon, we simply add the lengths of all of its sides. And that can be true all the way through down through this table for all of the polygons. As far as area for a square, we can multiply either the length of the side times itself, or to keep things simple, I'm going to say area is equal to either length times width or base times height. The reason I like base times height is because I can use exactly the same formula for the area of the rectangle and the same formula for the area of the parallelogram. So that gives me one formula that I can use for all of those figures. When I get to the triangle, I'm still in the trapezoid. I'm still going to find perimeter by simply adding the lengths of all their sides, but the formula for their areas is slightly different. The formula for the area of a triangle is either 1/2 times base times height or base times height divided by 2. And for the trapezoid, I'm going to take half of the sum of the two bases and multiply that number times the height. Or you might think about the trapezoid as having bases of two different lengths. So in other words, we're going to average them, hence the base 1 plus base 2 divided by 2, and then multiply that average base length times the height. For the circle, we typically don't talk about perimeter of a circle, but we use the word circumference to talk about the distance around the outside. Remember, we find circumference of a circle by either doing 2 times pi times the radius or pi times diameter. And the formula for the area of a circle, area equals pi times r squared. Now notice the pi in each of these formulas. Unless we're told to round, we're always going to leave our answer in terms of pi for the circle. That's kind of important to note. So unless we're told otherwise, leave circles, area, and circumference in terms of pi. So let's go ahead and take a look at some examples involving area. In example 1, it says find the area of the trapezoid graph below. Since that trapezoid is put very neatly on the coordinate grid for me, I can simply use my formula for the area of a trapezoid, 1/2 times base 1 plus base 2 times the height. And as always, with any formula, if I want to use it, the very first thing I need to do is go ahead and put it down on paper. So this top base from J to K is 3 units. This bottom base from M to L is 7 units. And the height, remember, has to form a right angle. So that height, the distance between the two bases, is 3 units. So I'm simply going to go to my formula, and then for the first base, I'm going to substitute a 3. For the second base, I'm going to substitute a 7. And then for the height, I'll substitute a 3. And then I'm going to grab my calculator, and into my calculator, I'm going to substitute in 1/2 times the quantity 3 plus 7 times 3. My calculator tells me that this number of square units in that trapezoid is 15. But what happens when the figure that we're trying to find the area for is none of those shapes for which we have an area formula? For instance, if we look at that quadrilateral that's been drawn in the coordinate grid below, we don't have a formula to find the area of that quadrilateral. Well, that's where we're going to be a little bit clever and a little bit sneaky about this. I'm going to go ahead and begin by drawing a rectangle that completely surrounds that figure for which we're trying to find an area. And I'm really going to begin by finding that area of the entire rectangle. And once I know the area of the rectangle, I'm going to take away the area of the red triangle, I'll subtract the area of the green triangle, take away the area of the blue triangle, and then lastly, I'll take off the area of the purple triangle, and what I'll be left with is the area of my resulting quadrilateral. So I could say that the area of my quadrilateral is going to be equal to that of the rectangle. Subtract, I'll call the red triangle triangle 1. I'll call the green triangle subtract triangle 2. Subtract the blue triangle. And then lastly, subtract the purple triangle. So that's kind of my strategy here, is to find the area of each one of those figures and then subtract them all from the area of the rectangle. So for the area of the rectangle, I'm going to tell the person reading my paper exactly what I'm finding here and the formula that I'm using to find it. So if I count up the number of squares in the base and height of my rectangle, I find that that rectangle is 13 by 14, which makes its total area 182 square units. For a triangle, the area formula is 1/2 times base times height, or base times height divided by 2. And that triangle has base and height of 9 and 4, which when I substitute into my calculator tells me the area of that triangle is 18 square units. And I should number these 1, 2, 3, and 4. For the blue triangle, I've already put the triangle formula down on my paper, so I can go ahead and I can substitute right into the formula. So I'm getting the base and height of that triangle to be 7 and 6, making its area 21 square units. I guess I have to go and do triangle number 2. Its base and height are 6 and 10, making its area 30 square units. And then lastly, triangle number 4. Which has base and height of 8 and 4, resulting in an area of 16 square units. So lastly, to find the area of my quadrilateral, I'm going to start with the rectangle. From that, I'm going to subtract the areas of the rectangles. When I do that, I find that the area of the resulting quadrilateral is 97 square units. And it's very important that as you work through this process, you identify exactly what you're finding areas for, um, so that in the event that you make a mistake, it's easy for your math teacher to go back through and assign you some partial credit. And it's just good to show all of the mathematics. Remember that the communication is as important as knowing the actual math itself. As always, thank you for the gift of your time. Do take a few minutes, summarize the key ideas and the essential understandings that you need to recall from this lesson, and then see if you can apply your newfound knowledge and skills to solve the questions on the next page.